Hello everyone, my name is Nick Fenter. I'd like to welcome you to today's webinar, which is named Is Geomorphic Reclamation Better Than Traditional? Our presenter today is Jake Anderson. Jake is a Maptek geologist and provides technical support to our Maptek users here in the North American region. Jake's also one of the brightest and tallest geologists that I've had the pleasure of knowing. So a few things before we get started, folks. First, today's webinar will conclude with a question and answer session. So feel free to write the questions in the panel on the right-hand side. You'll see on this little screen there, it says enter your message here. And also, you'll receive a link to this recording of this webinar by email. In case you want to see it again, it will be available on our Maptek website at a later date as well. So there's almost no chance of missing this. I'll hand you guys over to Jake. Jake, take it away.
Thanks, Nick. Thanks for everyone joining us today. We have a well-rounded group of attendees joining from multiple continents. In addition, we have people joining from all different areas of mining and environmental sciences. My name is Jake Anderson, and I will be your technical expert for this webinar. I'm really excited to be here. As Nick said, I am a geologist with the Maptek North America Technical Services Department. I have experience in resource modeling, exploration, and reclamation design. I became especially interested in reclamation design back when I would create reclamation bond designs while working in Wyoming. Thankfully, with Maptek, I get the opportunity to assist clients with reclamation design work on a regular basis. So today during this webinar, we will follow this agenda. We will be talking about how geomorphic reclamation is associated in the mining process, why plan for geomorphic reclamation, why geomorphic reclamation and how it's applied for different terrains, and examples of geomorphic reclamation design for different terrain types. So now we will discuss the geomorphic reclamation in the mining process. This can be subdivided into two main categories. The first category will be sin mining reclamation, and the second category will be post-mining reclamation. The first category in the mining process is reclaiming while mining, which is sin mining reclamation. This is a process that can be done efficiently during the mining process, where an operator is mining both ore and backfilling and actively regrading and placing topsoil and waste material in the backfill. This is a process that can also complicate short and mid-range planning by causing multiple and detailed steps, and any interruption in the mining process can cause a delay for the short term and also cause issues with the planning of a long-term plan. The pros to this method is that you're reducing your liability, and also you're utilizing equipment that is at the mine site, as opposed to if the mine be closed and became under financial stress. Normally, that equipment fleet will then be liquidated to preserve capital expenditure. The second topic is reclaiming post-mining. And this is typically a process that occurs to old abandoned mine operations. The reclamation for post-mining typically occurs with a deposit that has ceased operations. Therefore, the purpose and the emphasis of this reclamation is to quickly and adequately remediate hazards while trying to reduce further erosion from the ceased mine operation. This does not have the advantages of sin mining reclamation due to the fact that revenue streams have ceased for this operation. Therefore, there is less flexibility, and the idea of this reclamation is to just fix the solution as needed. So why plan for geomorphic reclamation? As resource extractors, we have the responsibility to efficiently extract material in a cost-effective and responsible manner. This extends to reclamation techniques. Reclaiming mined land to a status that existed or is more complementary to previous land status should be a priority of all mining operators. Advances in geomorphic reclamation improve mine land reclamation, which ultimately helps make mining better. This is why I care so much about it. Here are some pros for geomorphic reclamation. Geomorphic reclamation can reduce erosion, create diverse restored ecosystems for both flora and fauna, and also create state and local buy-in for responsible resource extraction. In the far right of your go-to webinar, you will now see a poll for a poll question that hopefully you can now go ahead and answer, and we will address the responses at the termination of this slide. So ways that you can plan for geomorphic reclamation. One item is you can construct a robust post-mine topography. In the United States, a post-mine topography is a requirement for an annual permit, and that is corresponding to the operator designing a surface that best reflects what they anticipate their topography to look like after they cease operations. This is a good starting point to identify how you want your topography to behave and look once you've completed your operation. The second way to plan for geomorphic reclamation is to schedule waste like ore. This is complex, but at the end of the day, you can go into a cut or an excavation and confidently know where that material will be landing in the backfill. This schedule can increase productivity and allow, with the utmost certainty, based on suitable or unsuitable materials are handled in a correct manner. This will speed up the reclamation process and allow you to understand where your material is going. And then finally, you can create dump designs that limit dozer activity. This is dumping almost to the final surface and to where you're dumping in a way that you are stacking benches and other features to limit the amount of dozer regrade. Oftentimes, the dozer is the tool for final regrade surfaces. And if you can limit as much unnecessary dozer movements, that is the key to creating a cost-effective reclamation plan. And as we can see in the poll, about 69% of you have said yes to the question, do you schedule waste material? And about 31% have said no. So now we will talk about geomorphic reclamation for different terrains. In this next section, we will propose 4 different terrain features, and we will present hypothetical geomorphic reclamation bench designs and dump designs, as well as final regrades for all surfaces. The 4 main terrain types that we will be talking about today are streambed or river channels, steep terrain, prairie or grasslands, and then finally a critical landform feature that is wetlands. The first example is streambed and river channels. Here in this example, you can see a life of mine pit that has progressed its pit shell into a known natural occurring meandering stream channel. Now, during the mining process, this stream channel will be diverted in order to prevent any water entering the pit and inhibiting the mining process. As this pit progresses, there will be multiple backfill that will be occurring at where the pit has progressed. And that backfill will then need to be used as material to infill the pit. It is critical that all mining operators that interfere and disrupt river systems should restore the river system in the best capacity that they can in order to preserve downstream water for all animals and also humans. Here is a geomorphic reclamation dump design for this feature. As you can see, benches have been dumped to not only preserve the gradient and the actual and create a new channel for the river system, but there's also an additional feature that is commonly associated with the anastomosing fluvial complex, and that is an oxbow lake. This oxbow lake was created to create a diverse terrain and also induce different ecosystems. Not only are we responsibly restoring the stream to its natural state, we are also inducing diverse terrain, so that way we will leave this mine better than what we came to it. Here's the final regrade for this stream situation. As you can see, there's proper drainage for the whole topography that once encompassed the pit and all backfill benches. That can be symbolized by no kinks in the contour layers, and there's multiple different divides that are allowing equal drainage for all surface runoff. In addition to the previously mentioned oxbow lake that was created from the dump design, now the reclamation engineer and all range management personnel for the operation have the opportunity to plant diverse and different types of plant life in order to create different vegetation. With an oxbow lake, this presents the operator with an opportunity to plant a diverse type of plant material such as softwoods, shrubs, or even lacustrine type plant life in order to induce biodiversity and also allow food for different species of animals. Our next example is going to be a steep terrain example. In this example, we have a pit that has been constructed in a mountainous terrain. Now, steep terrain poses a difficult problem for geomorphic design. And that fact is that not all material can be placed in a final placement exactly mimicking natural topography. So in this situation, we will create a series of dumps to create different benches, and that way we can create a diverse topography, but at the same time ensuring drainage and also slowing down any surface runoff to prevent erosion. Here is the reclamation design. As you can see, we have many benches that have created terraces, and these stacked terraces will potentially create wonderful habitat for ungulate species such as elk and deer. Also, different plant life can be planted along these benches, creating biodiversity within the reclaimed land. As you can notice, the upper benches of this deposit were not backfilled. This is because we will slightly regrade the upper benches, but we will also allow the upper benches to return to natural angle of repose. This is because some species of sheep and mountain goats, especially here in the western US, prefer to have parallel migration corridors and steep terrain that allow them to travel back and forth and also be able to visibly see any predators. Finally, here's the final reclamation and regrade of this geomorphic reclamation for the steep terrain. As you can see, we have two different preferential areas and avenues for surface water to run off on. But note that these contour lines indicate that this is not a steep gradient. This is a gradual gradient in respect to where the former high wall benches that we did not backfill. This is to slow down water and also create natural terraces within this feature. And you can see that we have slightly regraded these upper high wall benches as well. Our next example is a prairie or grasslands. Typically, deposits that exist in prairie or grasslands are considered horizontal and oftentimes are stratigraphic in nature. These deposits are often wide space over large or a vast expanse of kilometers or miles. Typically, it is common to see either dragline or dragline and truck shovel operations in these types of scenarios. In this life of mine image, we have a dragline and truck shovel combination pit. As the truck shovel fleet removes all pre-strip and hauls it with the trucks and sequentially dumps it with the trucks, the dragline is therefore excavating a bulk of the material and then backfilling it by a series of passes, which are kind of indicated by these chevron shapes. Typically, grassland has either long drainages that are very shallow in grade, or they are a sequence of rolling hills. So we are going to create this, which is a geomorphic dump design for this type of topography. As you can see, there are topographic highs that are not exceeding the natural topographic highs in the region. However, we are using the dump design to differentiate different drainages that will drain in opposite or the same directions meeting at a confluence to allow efficient drainage and restore previous drainage areas prior to mining. This can be done by creating a series of benches and then designing these benches to dump out to almost the top of the topography. Finally, once the reclaimed benches have been dumped, now final dozer regrade can begin. you can see that this smooth topography greatly blends in with the surrounding topographic highs and lows, while also securing the differentiating drainages that we had designed from our previous dump design. This is an efficient dump design, and the effects that water will not pond or pool, and we'll have equal drainage, and we have a diversity of drainages in multiple different directions. This will ensure that wildlife has habitat to hide and bed, while at the same time having a diversity and potential plant life that could help influence and create biodiversity. Our final example is a very critical example. Here in the US, there are regulations that state for however many acres of wetland that you disturb, you're required to restore exactly that amount. Wetlands are critical for mining reclamation because they can also, they create biodiversity after the mining is done, but they can also aid the remediation and also accelerate mining reclamation by the ability of wetlands to be able to soak up heavy metals that are considered toxic. Some mining operations have minerals such as pyrite that naturally decompose into acid mine drainage. Wetlands can help inhibit the distribution of acid mine drainage by being situated near key discharges that can then have the wetlands be used as a sponge to soak up some of those heavy metals, so you're not discharging those metals downstream and harming plant, animal, and human life. Here is an example of a wetland dump design. In this design, each contour indicates that it is 1.5 meters in height. This design, and all designs for wetlands, should try to achieve a shallow depression. This depression should not be so deep as in you are creating a mini lake, but it should be shallow enough that you can create these benches that will inhibit different types of aquatic plant life as well as animal life, but at the same time, it is shallow enough yet deep enough that water can pass through and move through all parts of this system, but allowed to be able to overflow if possible during peak storm events. These benches will also allow silt to be deposited, so over time, this wetland will be able to have the ability to behave like a natural stated wetland. Once these benches are succumb to final regrade, you can see here that the final regrade contours are indicating that there is a slow yet gradual grade that encompasses the entirety of this depression. You can see the terminus of the depression here, as well as the very gradual yet topographic high divide that is going to allow overflow water to exit the system. Finally, you will see here that the depression, this is the anticipated ponding of this wetland. This water is critical, and yet it is not deep because these contours, again, are 1.5 meters deep, or high, and this water is expansive and it covers a lot of surface area. This will allow a lot of plant life, and especially cattails and reeds, to access and utilize this area with effectiveness, therefore increasing and leveraging the pros in both environmentally and for reclamation for these wetlands. Is geomorphic reclamation better than traditional? Yes, when an efficient schedule is created, when you need to direct place topsoil, when you need to create different micro ecosystems, and finally, when you're establishing mine lands to mimic the natural topography.
Well, thank you, Jake. It was great to see some rehabilitation in action. So let's head over to the questions portion of this. So please write in any questions that you might have on that panel on the right hand that I spoke about in the beginning of this webinar. And then I'll go through some of the questions we've received so far. So Jake, are you ready?
I am.
Excellent. Okay, Jake, so one of the first questions here is, what software are you using for these designs?
So the two softwares that are being used, primarily the main software that I feel is very dynamic in creating reclamation surfaces is a third-party software called 3D Dig. So a lot of these screenshots were of 3D Dig and Maptek's flagship software, Vulcan. They both present a lot of tools that are very dynamic, easy to use, and actually create very nice designs that you'll be pleased with. And I really enjoy using them.
Excellent, thanks, Jake. And then it looks like someone really listened to my intro there. They're asking exactly how tall are you, Jake?
I am 7 foot tall.
Excellent. Would you mind putting that in metric for us as well?
Oh, geez. Hold on. I might have to get the all the Australians that are listening to this are rolling their eyes right now. I am 2.1 meters tall.
Awesome, thanks. Okay, then another question here that I've got is, in your experience, how frequently do you see mining dumping as close to the final topography as possible?
I've seen a lot of people do it pretty effectively. You know, the way that, you know, it can be really done dynamically is with like a decent amount of dozer assist. And nowadays with dozers and shovels and trucks that have active terrain software, being able to dump as close as possible to that final surface is becoming more of a standard practice, which is really nice to see because it induces a lot of efficiency and cost effectiveness.
Excellent, Jake. Thanks. We've got another question here that says, are you using the drainage tools in 3D Dig to show the ponding? Have any of these tools improved recently, or are there any plans to add any other functionality to the reshaping drainage tool?
So I can't absolutely speak on the behalf of 3D Dig just because you know, they're working on their specific developments. But the drainage tool, from my opinion and experience with it, has increased in functionality tremendously in the last 3 to 4 years. With the ponding example that I showed, that was a direct result of the reshaping module and the ponding tools within 3D Dig. And to my knowledge, they're adding more and more functionality, and it's going to continue to improve.
Excellent. And then this is like a question, but maybe more like a statement. It would be nice to see a raindrop tool showing drainage pathways, if ever possible. Don't know if you want to elaborate on that, Jake.
Yeah, so something that wasn't shown was the catchment analysis. The drainage tool also will show your catchment areas where it's just the general basin of the drainage to just show you where water will collect and drain to. And so that, to my knowledge, is a functionality that you can use now.
Excellent. And then I've got another question here for you, Jake. You're getting peppered with questions, so prepare yourself. Do you always use native material that is already in the remediation area to reshape the ground, or is there ever a reason to use different types of material when reclaiming?
So a good example of that would be my stream bed example. So a lot of times it would be beneficial to identify where those native sands were and stockpile them in a special area, so then you can go and dump that material back to its relative location. And the pros to that is you're actually restoring subterranean aquifers while you're doing that. Now, the only other time that you would want to take material that is not native and place it is in a situation where you have unsuitable material that, if it's succumbed to erosion or hydration, that could cause water runoff that could be laden with metals or toxic material that you would want to cap. And creating that capping rock will secure an aquitard around that hazardous material that is buried at depth and help prevent it from causing problems many thousands of years after the mine is done and completed.
Awesome, thanks, Jake. And then I just saw a comment from our mutual colleague in South Africa saying that the drainage tool has been added, and there's functionality that allows one to see the volume in the ponding and the time it takes to pump into a given area at a certain pump speed. So maybe that's just important for the folks to know.
Yeah, and in addition to that, you can design different polygons to replicate different sump pumps to also help with if you have like more than one sump pump that you want to pump the water out of the bottom of your pit as well.
Excellent, thank you, Jake. Well, I think that wraps it up for today. We're nearing the end of our time. And then if you've got additional questions, feel free to contact Jake directly or email us at support@maptek.com. On behalf of the entire Maptek team, thank you for attending and have a great day.